Hi, question number 7 taken from October 2016, advanced level further maths from the CIE exams, code 9231, paper 1. The curve C has equation y is equal to e to the minus 2x. Find, giving your answers correct to 3 significant figures, the mean value of dy by dx over the interval 0 less or equal to x less or equal to 2 marks. For the second part, the coordinates of the centroid of the region bounded by C, x is equal to 0, x is equal to 2, and y is equal to 0. 9 marks for the second part. Now for a question like this, I would rather sketch the curve just to have an idea of what's going on here. So this is x and this is y, and this curve is going to look a little bit like this. This is y is equal to e to the 2x minus 2x. If this is 0, this is going to be equal to 1, and this is going to be equal to 2. Now, is the curve continuous? Yes, this function is a continuous function, so it meets the first condition for a mean value theorem. And is it differentiable? Yes, it is. This can be differentiated. And somewhere in between 0 and 2, there could be a point, an x value here, we may call it C. At that point, the tangent is parallel to the secant. So this would be the secant. Alright, so it meets all the criteria when it comes to mean value theorem. And therefore, we can use the formula f prime of C is equal to fb minus f of A, alright, divided by b minus a. So what is basically f of b? Alright, so f of b here, we're going to be doing f of 2. So f of 2 minus f of 0, and that over 2 minus 0. And f of 2, if you replace 2 in here, you're going to get e to the power of minus 4 minus e to the power of 0, and all of that divided by 2. So a mean value for this is going to be, let's check it out from our calculator. So e to the power of minus 4, so e to the power of 0 is equal to 1, so minus 1, and then you can divide by 2. So the answer should then be minus 0.4912 significant figures. So minus 0.4912 SF. Okay, so this is the first part. Now for the second part, we need to calculate the coordinates of the centroid of the region bounded by C. X is equal to O, x is equal to 2, and y is equal to 0. So this is the curve y is equal to e to the minus 2x. The centroid, I don't know, it could be somewhere here, but it is the point at which if I put this graph on this point here, it's going to balance. So the formula basically is we need to calculate the area, okay, of the function, and then to get the x coordinates of the centroid, we put 1 over the area times x times the whole lot, and for y we're going to use this one. Okay, so let's proceed. Now we're going to have to calculate the area first. So what is A basically? Now A can be calculated if we integrate e to the minus 2x dx, and that's going to give us e to the minus 2x over 2, and basically we're looking at minus. Okay, so and you substitute the limits 0 from 0 to 2. Okay, and if you do that from your calculator, you're going to end up with 0.490842. Now that's the area, very critical, we need this. Now for the x coordinates of the centroid, we're going to integrate, we're going to put 1 over the area, which we just found, 0.4908 and so on, times the integral of the function. So times, therefore we're going to do, let us say, integral of x and then e to the minus 2x dx. So this is basically integration by parts. Okay, so if allow me to write here, we're going to say u is equal to x, and du is going to be equal to 1, dv is going to be equal to e to the minus 2x. If you integrate this back, you're going to get v as e to the minus 2x over minus 2. So this is uv, and therefore let me just write it as such, and uv is going to be minus x over 2 e to the minus 2x minus the integral of v du. So minus half times 1, minus times minus becomes plus, and we have half times e to the minus 2x dx, and of course this is going to lead to minus x over 2 e to the minus 2x minus 1/4, alright, e to the minus 2x, and the limits are 2 and 0. Okay, so if we substitute the limits for 2 and 0, we're going to end up with x, which is now 2 over 2 is 1, minus 1 times is minus e to the power of minus 4, because 2 times 2 is 4, minus 1/4 e to the power minus 4. Okay, that's the upper limit minus the lower limit, and if you put 0 in here, that's going to end up as 0, minus 1/4 then e to the power of 0. So if you proceed and you do the maths on your calculator, you're going to end up with 0.22715. Therefore the centroid, the x coordinate of the centroid is going to be this divided by the area. So we're going to take 0.22715 divided by 0.4908, and so let's do that. Double 27105 divided by 0.490, alright, 842, 0.4626 and so on, so 0.463. I'm happy with that. So 0.463, so that's the first coordinate, x coordinate. And now we need to find the y coordinate, and for the y coordinate we're going to use this formula. So let's deal with the integration first. So we're going to have to do some change here. Alright, so what are we going to do? We're going to say half times the fraction, which is, for this particular question, it is e to the power minus 2x, and all of that to the square. So what are we looking at? We're looking at half e to the power minus 4x, and therefore we're going to integrate that. Okay, and integrate that with the limits as 0 from 0 to 2 dx. If you integrate this, that's quite easy. So your half can go outside, times minus 1/4. Okay, and e to the power minus 4x, and of course your limits are 2 and 0. So that's going to become minus e to the power minus 4x over 8, limits to 0. So let us substitute the limits, and if we do that, you're going to put 2 here. That's going to become then e to the power minus 8 divided by 8, okay, the upper limit, minus the lower limit. If you put 0 in here, you're going to get minus e to the power of 0 over 8. Alright, so now if you do that on your calculator again, you're going to end up with 0.1249580 blah 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 and so on. So therefore the y coordinates of the centroid is going to be this 0.124958 and so on, divided by the area we found earlier on, so 0.4908. Let's do that. So 0.124958 divided by 0.4908, so 0.255. okay, so that should be fine. 0.255. Therefore, here we go. This is the coordinates of the centroid. So we have it as so this is should be your answer there. So 0.463 and 0.255. All right. So I hope this has been of help. Okay, let's take this away, and here we go.